Welcome to The Explainer. Today, we're diving into a mind-bending geographical mystery that's literally been hiding in plain sight for millions of years. We're talking about a story of survival against absolutely impossible odds. And the crazy thing is, it's not driven by magic, but by the sheer unforgiving geometry of our planet. Let's get right into it. Okay, let's dive into this. 159 degrees Fahrenheit. I mean, just think about that for a second. That staggering number is actually the highest land surface temperature ever confirmed by NASA satellites, and it belongs to Iran's Lut Desert. We really need to start here to set our baseline today. The Lut is this hyper-arid, brutally harsh environment. It's a basin of such extreme heat and low humidity that its very center is a confirmed dead zone. We are literally talking about a place where absolutely no living organism, not even bacteria or fungi, have been found to survive. But here is where things get almost unbelievable. You look at the left here, and we have the Lut Desert, lifeless, totally baked, defined by absolute extremes, right? But then look at the stark contrast on the right. Less than 500 miles away from that complete dead zone, sitting in the exact same country, lies a completely contrary ecosystem. We're looking at a lush, rain-soaked, perfectly intact, temperate broadleaf woodland. It's basically a complete ecological impossibility. Seriously. How does a damp, ancient woodland thrive in a region that is globally notorious for extreme heat, hyper-arid basins, and volcanic salt islands? Well, it turns out the Hyrcanian forest is an anomaly of the highest order, flourishing right on the margins of some of the absolute most unforgiving terrain on Earth. And to truly grasp the scale of this anomaly, just think about this number. 850,000 acres. That's the immense size of this temperate broadleaf woodland. It's like a massive, uninterrupted blanket of green stretching majestically along the southern coast of the Caspian Sea and northern Iran, pressed tightly against this rocky landscape. And we aren't merely looking at some modern marvel here. We are talking about a staggering scale of time. See, between 25 and 50 million years ago, this specific type of forest blanketed a huge chunk of the world. But then came the Pleistocene epoch, the last major ice age. Massive glaciation and drastically shifting climate zones essentially wiped out nearly all of these similar forests across the entire northern hemisphere. Yet somehow, right through to the present day, the Hyrcanian forest has persisted, completely intact. So, that brings us to the million-dollar question. How exactly did this specific forest survive when almost all the others like it died off? I mean, the Pleistocene glaciation, followed by the massive aridification of West Asia, these events absolutely should have erased this woodland from the map entirely. Its continued existence isn't just a lucky break. It is a profound ecological improbability. But here is the secret. The Hyrcanian forest didn't survive through some kind of unmatched natural toughness or biological magic. No, it survived because of a highly specific, almost mathematical accident of topography. Let's walk through exactly how this geographic machine actually works, step by step. First off, you've got the Caspian Sea, sitting right in front of the forest. Now, the sea basically acts like a giant natural humidifier. It maintains the constant, high moisture levels needed to sustain these broadleaf tree species. Second, right behind the forest, you have the towering Alborz mountain range, acting like a massive fortress wall. This physical barrier completely blocks the freezing cold air that tries to sweep in from the continental interior. So together, these two physical characters, the sea and the mountains, create this perfectly isolated, stable, temperate climate that is completely shielded from the outside world. So the crucial point here is that the forest survived by being, in climatic terms, in exactly the right place. It really isn't just about the sheer will of nature pushing through. The Hyrcanian's continuity is the direct product of these highly improbable geographic conditions that just happen to remain perfectly stable, shielding it from the dramatic, hemisphere-wide climate swings that devastated its peers. But you might be wondering, why does this geographic accident actually matter on a human level? Well, it matters because it serves as an ancient resource buffer. For the communities that have lived at the margins of this forest for literally millennia, this ecological anomaly isn't just some fascinating science fact. It is the very foundation of their daily survival and their economy. The sheer density of resources this forest provides to those border communities is just extraordinary. We're talking about wild fruit, edible mushrooms, medicinal plants, abundant game, and high-quality timber. And all of this incredible abundance is fueled by an annual rainfall that is several times higher than what you'd find in the arid interior of the exact same country. It's essentially a localized explosion of life sustained entirely by that trapped pocket of moisture we talked about. Just take a look at the whiplash contrast between these two zones. On one side, you have the Hyrcanian forest, with its high rainfall and temperate climate. On the other, the hyper-arid, completely lifeless Lut Desert. And remember, they are less than 500 miles apart. That right there completely proves that latitude isn't what's determining the climate here. The forest exists entirely because of that mountain and sea geometry, while the desert exists due to basin geometry and just relentless sun. But unfortunately, the story doesn't end with this ancient triumph of survival. This incredible 50 million year history of resilience is now giving way to a highly precarious present. That protective bubble, well, it's currently under siege. The very geographic buffers that kept the Hyrcanians safe for millions of years are now actively being squeezed. See, the forest is facing aggressive agricultural encroachment from the lowlands below, while simultaneously dealing with severe development pressure from the Caspian coast above. Now, while the deep interior does remain largely intact for now, these combined forces are actively reducing the forest edges. And that means the critical temperature and moisture buffers that protect the whole system, they are dangerously narrowing. We really have to remember what is truly at stake here. The forest's continuity is not just some natural abundance that will bounce back from anything. It is the product of conditions that happened completely against probability to remain stable. So when we start chipping away at its borders with modern encroachment, we aren't just removing trees, we are actively threatening the highly specific probabilistic physical conditions that allow the forest to even exist in the first place. Which leaves us with a pretty provocative final question to consider. What exactly happens when the climate corridor that has preserved this ancient world for 50 million years begins to shift? If this incredible relic is completely dependent on exact, unchanging geographic conditions, can it possibly survive the rapid changes we're bringing right to its doorstep? It's definitely a profound mystery to reflect on, and I think it's a perfect reminder that some of the most durable systems on Earth are also the ones we absolutely must be the most careful not to destroy. Thanks for joining me on this explainer, and definitely keep exploring.